For billions of years, the sun has been our source of life, illuminating the earth, shaping our seasons, and driving the processes that make life possible. But like all stars, the sun has a limited lifespan. One day, far in the future, it will transform, growing into a colossal red giant before shrinking into a dense white dwarf. But how does this transformation occur? What will happen to Earth and the solar system when our sun undergoes these cosmic changes? And what can we learn from other stars that have already gone through this dramatic fate? Join us as we embark on a journey through time and space to explore the sun's ultimate destiny. The sun, like all stars, follows a life cycle dictated by the complex forces of nuclear fusion and gravity. At the heart of our sun, hydrogen atoms fuse together, producing helium and releasing enormous amounts of energy. This nuclear fusion is what keeps the sun shining and prevents it from collapsing under its own gravity. Our sun is currently in what astronomers call the main sequence phase, a stable period that has lasted about 4.6 billion years. It will continue to shine like this for another 5 billion years before changes begin to take place. But what happens when the fuel starts to run out? As the sun consumes its hydrogen, its core will begin to shrink under gravity. But instead of fading away, a remarkable transformation will begin. The outer layers of the sun will expand outward, and the star will enter the subgiant phase. During this period, the sun will grow larger and cooler, shifting from bright yellow to an orange hue. It will become twice as large as it is today, marking the start of its inevitable transformation into a red giant. What does this mean for Earth and the other planets? After the subgiant phase, the sun will swell into a red giant, expanding more than 100 times its current size. Its outer layers will stretch so far that it may completely engulf Mercury and Venus. Earth will face a dire fate. While it might not be fully swallowed by the expanding sun, the intense heat will boil away the oceans, strip the atmosphere, and turn the surface into a lifeless wasteland. Mars and Jupiter's moons, once frozen, could become temporary habitable worlds as they bask in the red giant's glow. This phase will last a few 100 million years, a brief moment in the grand scale of the universe. But the sun's transformation is far from over. As the sun's core continues to collapse, the temperature will rise to 100 million degrees Kelvin, hot enough to ignite helium fusion. This process, known as the helium flash, will cause the sun to shrink slightly and burn more steadily again, temporarily stabilizing its expansion. But this second wind won't last forever. As helium runs out, the sun will lose its ability to sustain fusion, and its outer layers will be expelled into space, forming a planetary nebula, a stunning shell of glowing gas. At the heart of this nebula, a dense remnant of the sun will emerge, a white dwarf. The final stage of our sun's life is as a white dwarf, a super-dense, Earth-sized core that glows with leftover heat. No longer producing energy, this stellar remnant will gradually cool over billions of years, slowly fading into a cold, dark black dwarf, a theoretical object that no longer emits light. Though the sun will be gone, the remnants of its existence will linger. The expelled outer layers will enrich the galaxy with elements that might one day contribute to new stars and planets. The sun's transformation is inevitable, but it won't happen for billions of years. By then, humanity may have evolved into a spacefaring civilization, colonizing distant worlds, or even migrating to other star systems. But the sun's story is not just about the fate of our own star. It tells us about the life cycles of stars everywhere in the universe. Other stars, like Betelgeuse and Aldebaran, are already in their red giant phases, offering us a glimpse into what our own sun will one day become. The death of the sun is not an end, but a continuation of the great cosmic cycle. Stars are born, they shine, they evolve, and they pass their elements on to the next generation of celestial bodies. Our sun is no exception, and though it will one day fade, Its legacy will live on in the atoms that make up our planet, in the stardust that created us, and in the endless expanse of the universe. Thank you for watching. If you enjoyed this journey through time and space, don't forget to like, subscribe, and explore more of the wonders of the cosmos with us. See you in the next video.